here, and I'm believing that by the time we are done with this workshop, we will have wonderful insights that can drive the conversation even further and make it much more impactful. You are welcome to KNUST, and we are so happy to have you here. And I hope that you are going to enjoy your stay while we are at it. We would want to start the event, and to start, we would take a welcome address from the professorial representative on the University Council, Professor Samuel Asarin-Kansa. Please appreciate him as he comes to do that. And he is doing that on behalf of the Vice Chancellor of the university, who is unavailable this morning. Please appreciate him as he comes.
Good morning, everyone. For our guests who traveled from overseas to join us, I hope that you had a safe flight and you have enjoyed the few days that you have been in Ghana. This morning, for other competing reasons, the Vice Chancellor couldn't be here with us, and she extends her regards and would want me to represent her in providing this welcome address. The Honorable Ashanti Regional Minister, the Director of National Communications Authority, Deputy Director, Ministry of Environment, Science and Technology, the National Coordinator, Responsible Cooperative Mining and Skills Development, the Regional Director of Food and Agriculture, Directors of CSIR Soil Research Institute and Crops Research Institute, immediate, past, and current provosts of the College of Agriculture and Natural Resources, deans, heads of department, other senior members of Faculty of Agriculture, Dean International Programs Office, KNUST, our cherished international scientists from Africa, Europe, South America, Oceania, and many others. Distinguished media, ladies and gentlemen, good morning. It is a great pleasure to welcome you all to the Kwame Nkrumah University of Science and Technology, Kumasi, for this very important international workshop. And I am highly honored to deliver this welcome address on behalf of the Vice Chancellor, Professor Mrs. Rita Akosua-Dixon, who sincerely wished to be here personally, but for equally important reasons, as I have already mentioned. The purpose of the first European Joint Program See Around workshop, ladies and gentlemen, is to discuss scientific insights in regenerative agriculture and soil carbon sequestration across the globe. And as a health professional, anything regenerative is of much interest to us. In this era of climate change and soil degradation, regenerative agriculture targeted at greater soil carbon sequestration, soil health improvement, biodiversity conservation, and improved crop productivity, and so on, is very critical. Promoting circular economy through circular agriculture is very important to ensure food security whilst maintaining environmental health and climate resilience. It is therefore very welcoming to have seasoned scientists across the globe focusing their research attention on this. It is with great pleasure that 13 good institutions collaborating on the projects across Africa, Europe, South America, and Oceania are here this morning to deliberate, to address the theme of the conference. The synergy between these diverse institutions and multidisciplines will undoubtedly yield cutting-edge outputs in steering regenerative agriculture and food security, not only in Africa, but also across the globe. As a sustainability-driven university, we are much excited about this workshop. The 5-day workshop, ladies and gentlemen, combines several important activities ranging from high panel discussions to very insightful scientific presentations, hands-on training for youth from the KNUST Senior Secondary School, field trips to the African Dark Earth sites in Ghana, among others. These are very much well in place. The Kwame Nkrumah University of Science and Technology, Kumasi, embraces cutting-edge research in ensuring the sustainable development goals of no poverty, zero hunger, climate action, through all the 6 colleges of this university. And I must emphasize that all that we have to do towards achieving the SDG goals, time is gradually taken by, and within the next 5 years, we are hitting the target, and so we have to speed up the actions. The university will continue to promote multidisciplinary cutting-edge research in the global and national domain through provision of its skilled human resources and the enabling environment for the research. Your participation in this workshop will further facilitate this drive. As you journey through these few days in Ghana, let us remember to connect, interact, and foster extensive collaborations between academia, industry, and policy. This is the only way that we can help secure food security and resilient environment. Our guests from the diaspora would want to invite you to enjoy our green environment as a university. Before I conclude, I would want to extend a heartfelt congratulations to the organizing team led by one of our Nobel professors, hardworking, Professor Vincent Luga, who is a PI as well and head of department, and all the other members that have helped put this program together. I would want to acknowledge the presence of all of you here and your participation, and would want to warmly welcome you to this very important event, and also to declare this workshop open. May you have very fruitful deliberations. Enjoy your stay in Ghana. And for those of us who might have not come to KNUST campus for a while, explore the new environment and have a story to tell when you go back. Thank you very much for your attention.
Please appreciate Professor Samuel Asarin-Kansa once again. That was a very forward-looking and inspiring message coming from the university to welcome us all. And definitely, I hope you do enjoy your stay for the next few days ahead. At this point, we will take another speech from the Dean of the International Programs Office, who is the pillar fostering global partnerships here in KNUST. Please appreciate him as he comes to do that for us.
Good morning to you all. The good morning was to everybody. Good morning to you all. Please, the appreciation, if you can add a little bit more to it, please. Let's clap. Thank you all so much. Professor Samuel Asare-Nkansah, kindly permit me to stand on the existing protocols which you have beautifully laid to continue with my speech. On behalf of the International Programs Office of the Kwame Nkrumah University of Science and Technology, it is my honor and joy to welcome you to our campus and to the historic city of Kumasi, the cultural heart of Ghana and the seat of the Asante Kingdom. Today, we gather under the banner of science and shared responsibility, the responsibility to protect our land, restore ecosystems, and ensure that progress does not come at the expense of planetary health. The European Joint Program, arouNd, represents exactly the kind of transnational collaboration that our office seeks to foster. One that is grounded in mutual respect, knowledge exchange, and enduring partnership. At KNUST, we believe that international cooperation is not only about the mobility of scholars, but about the mobility of ideas. Ideas that travel across borders to improve livelihoods and transform societies. Through this workshop, we are proud to host colleagues from Europe, Latin America, North America, and across Africa who are jointly redefining how soil carbon, greenhouse gases, and regenerative practices are studied and applied. As the International Programs Office at KNUST, our mandate is to make such engagements seamless in order to connect people, institutions, and cultures in ways that advance scientific discovery and sustainable development. We are delighted to see this realized through the collaboration between 13 institutions in countries spread over almost the entire continent, and of course, our communities in Ghana. To our visitors joining us in Ghana for the first time, we say, Akwaba. You are most welcome. We hope that beyond the academic sessions, you will take time to experience our hospitality, explore the KNUST Botanical Gardens, and feel the warmth and vibrancy of Kumasi's people. We definitely have this on the program, so enjoy that. Let us use this week not only to discuss data and models, but also to build trust, friendships, and long-term pathways for a regenerative change. I urge us all to leave this workshop with a renewed conviction that sustainable practices and climate action must go hand in hand, informed by science, guided by policy, and inspired by humanity. I wish you fruitful deliberations, enjoyable interactions, and a memorable stay in Ghana. Thank you very much.
Thank you, Professor Dia. Please do well for him, do better for him. All right, and definitely I hope you enjoy your stay, especially in Kumasi. You have wonderful things to look out for when you are here. By way of housekeeping, may I remind us that washrooms are available on the other side of this auditorium. So if you want to use a washroom, you can use either this exit or that. Or you can even go out from where you came from and go all the way down there. You would find them, they are labeled both for males and females. And so please, or as well, you can talk to the ushers over there and they will assist you nicely to be able to find your way there. At this point, we'd want to take another speech from the representative from the Soil Research Institute. Please appreciate him as he comes.
Thank you very much, Madam. Good morning to you all. My name is Dr. Patrick Ofori. I am the Deputy Director of CSIR Soil Research Institute, and my director has asked me to represent him on this program as he's on another assignment in Accra. Representative of the Vice Chancellor of KNUST, may I seek your permission to stand on the existing protocols and make my speech. On behalf of the Director and Management of CSIR Soil Research Institute, I wish to express our profound gratitude to the organizers of this program for the invitation to participate in this maiden EJP arouNd project workshop in Ghana. CSIR Soil Research Institute is one of the 13 research institutes in Ghana under the Council for Scientific and Industrial Research. Our mission is to generate scientific information and technologies for the planning, development, and management of Ghana's soil resources, promoting sustainable agriculture, industry, and environmental quality. Our vision is to become the center of excellence in research and management of the soil resources of Ghana for sustainable agriculture and environmental quality. Our key objectives are: 1, to strengthen the Institute's delivery capacity for increased agricultural food production, to establish and strengthen linkages with local and international institutions, to develop and promote sustainable agricultural practices, and to commercialize our research findings. We at SRI leverage the skills and knowledge of our scientists and technicians from 5 key divisions, namely the Soil Genesis, Survey, Mapping, and Classification Division, Soil Chemistry and Analytical Services, Soil Fertility and Plant Nutrition, then the Soil Microbiology Division, as well as the Soil and Water Management Division. Over the years, CSIR Soil Research Institute has been at the forefront in championing the need to recarbonize our highly weathered soils through the dissemination of sustainable soil management technologies to farmers. And key among these are the application of organic amendments such as biochar, manure, compost, and other crop residues. We are of the firm belief that in this era of climate change, one of the safest means to reduce carbon emissions is to put back carbon into the soil in a much stable form. SRI is a key partner in the implementation of the EJP program in Ghana, with one of our staff members currently enrolled in the PhD program under the supervision of Professor Loga and Dr. Edward Yeboah. We believe that our participation in this maiden workshop will strengthen our partnership with EJP and also open doors for further collaborations with other partners. I wish you all a fruitful workshop and enjoy your stay in Ghana, those of us coming to Ghana for the first time. Thank you very much.
Thank you, Doctor. Thank you so much. And to your team for all the work you do around here for our crops and our soil and every other thing agriculture. We are taking another speech still from CSIR, but this time from the Crop Research Institute. Please appreciate them as they come. Oh, we can do better. Are we hungry?
Good morning, everyone. Good morning, Prof. Chair. I want to stand on the protocol that you have established already and proceed. I want to say I'm going to save you some time so that we can take more speeches and be able to also conduct the workshop on time. So my name is Dr. Eric Owusu Dankwa. an expert in cropping systems and agroecology. And I'm here representing the Director of Crop Research, Professor Maxwell Asante Daakon, and also representing CSIR Crops Research Institute. So CSIR Crops Research Institute is the largest of all the 13 institutions under CSIR. And we are the premier research institution across Ghana. This one I can say with all boldness, and I hope you agree with me. We are dedicated to sustainable farming and sustainable systems that help promote improved productivity, especially in the face of climate change. And a workshop that is looking at regenerative agriculture, greenhouse gas emissions, and soil carbon sequestration is something that falls within our vision and mandate as an institute. We develop technologies which help promote the reduction of GHGs, help improve crop productivity, and improve farmers' livelihood. So this is a workshop that we are happy to be part. I would want to say that we are grateful to the organizers for inviting us to be part of this very important workshop. And we want to say that we are happy to share our knowledge and our expertise. Although I'm representing crops research, I see a lot of colleagues from crops research here. And they all pledge that they will share their expertise and knowledge to make sure this workshop is successful. Thank you very much for your attention.
Thank you, Dr. Dankwa, for this wonderful one as well. So we are still taking the speeches, and I'm hoping that while we are at it, we are taking notes and then seeing how we can also contribute to the conversation going forward. And at this point, we'll take another one from the Regional Director of the Ministry of Food and Agriculture, MOFA, the Regional Director, Mina Ashanti Region. Please appreciate him as he comes to do us the honors.
Good morning. All protocol observed. It is with great honor that I join you at this important gathering, the first European Joint Program See Around Project Workshop here at KNUST. I wish to express my appreciation to the organizers, particularly the CSIR Crops Research Institute and the See Around Network for extending the invitation to Ministry and Department of Food and Agriculture in Ashanti region. This workshop brings together experts in agriculture, climate science, land restoration, and sustainable development. The thematic focus: regenerate agriculture practice, greenhouse gas reduction, and soil carbon sequestration in both timely and essential to the future of agriculture in Ghana and across Africa continent. As a region and as a country, we are at a turning point. Agriculture remains the backbone of our economy, a source of livelihoods for millions and critical pillar of our national development. Yet we face rising challenges, including land degradation, declining soil fertility, unpredictable rainfall patterns, and temperature increases associated with climate change. These challenges are not abstract. They are experienced by farmers across Ghana and the sub-region. To sustain production and ensure food security, we must shift from extractive practices to regenerative and climate-smart agricultural systems. We must rebuild soil health, enhance organic matter, reduce greenhouse gases, and promote water-efficient and resilient farming methods. This requires innovation, research, knowledge sharing, and long-term partnerships. The See Around project ensures an important platform for collaboration where Ghanaian scientists and practitioners can work alongside international partners to develop, test, and scale sustainable solutions. Such collaboration strengthens our research capacities and helps ensure that innovations do not remain confined to laboratories or academic publications, but are transferred to farmers' fields and communities, which are of great interest to us as a ministry and department. Our farmers are ready to embrace change. What they require are accessible technologies, effective extension support, viable markets, and right incentives. The Ministry and Department of Food and Agriculture are committed to working with KNUST, CSIR, and private sector and farmer organizations to promote soil conservation, agroforestry, climate resilient seed systems, and efficient irrigation water management techniques. However, the most important step is ensuring that the knowledge developed in research institutions translates into everyday practice. No innovation is meaningful unless it is applied where it matters most. That is, on the farms that feed our country. As we participate in this workshop, I encourage all of us to think collaboratively. The knowledge generated here should directly influence agricultural planning and resource allocation, both at national and regional levels. Together, we have an opportunity to position Ghana and Ashanti region in particular as a leader in climate resilient and regenerative agriculture in West Africa. In closing, I wish to acknowledge the dedication of all researchers, development partners, extension officers, and farmers working tirelessly to transform our agricultural system. Let us continue to work together to restore our soils, improve productivity, strengthen food security, and build sustainable agricultural landscapes for the generations to come. Thank you, God bless you, and God bless Ghana.
Oh, please add a little. I beg you. Okay, thank you. Thank you so much, sir. We take another speech from another stakeholder, and this one will be coming from the president of the Soil Science Society of Ghana, Dr. Edward Yeboah. Please appreciate him.
The representative of the Vice Chancellor of KNUST, Professor Samuel Asare in Kansan, the chairman of the organizing committee of the first EJP arouNd project workshop, distinguished international scientists, invited guests, the print and electronic media, ladies and gentlemen, all other protocols fully observed. It is with great honor and privilege to deliver a solidarity message from the Soil Science Society of Ghana on the occasion of the first EJP arouNd workshop in Kumasi, Ghana. This is the first physical scientific workshop of the consortium, and we are proud to be associated with this historic scientific meeting. There has been several virtual meetings that we have all participated, but this is the first physical scientific meeting of the consortium. The Soil Science Society of Ghana is made up of soil and environmental scientists committed to providing experts' knowledge to orient policies in sustainable soil management in Ghana, identify knowledge gaps, and define a research priority agenda. The Society's membership in Ghana are found working in the research institutions, the public and private universities, international and local development partners, and then the private sector. The Society is linked with the African Soil Science Society at the regional level and the International Union of Soil Science. Senior members of the Soil Science Society of Ghana are working effectively within the various commissions of the International Union of Soil Science. The Society works closely with the Global Soil Partnership of the Food and Agriculture Organization, as well as the African Soil Partnership. The current focus of the Society is to work towards delivering a framework for a sustainable development, implementation, and maintenance of the Global Soil Information Systems, the GLOSIS, components including regional and national systems and their integration into the global network. It is worthy of note that the Ghana team of the consortium have organized historical and metadata of the Ghanaian African dark earth and adjacent farmlands. Again, it has come to the notice of the Society that the Ghanaian team have characterized sites and profile descriptions, including all the major soil forming factors, that is the climate, topography, landform, position, parent material, vegetation, land use history, according to the international standard World Reference Base for Soil Resources, WRB 2022, 4th edition. This information will be relevant to the ongoing work of the Soil Science Society of Ghana, particularly in working towards developing a dashboard for soil monitoring across the country. Again, these outputs will be relevant in the model development that is being done by the Society and the associated institutions to come out with a monitoring framework that will be used to guide the soil resources of the country. And at the continental level, with the African Union Soil Observatory and the West African Hub. These ones are all linked up with the European Union Soil Observatory framework that is being done. So we are of the view that the data emerging from the consortium would also be available through shared principles so that this can be used in the model exercise that is currently underway. At the international level, we are seeking a collaboration and synergies with EJP to maximize the impact and potential of the network. Furthermore, the Society is keen and eager to recognize and address areas where further research is needed to advance soil carbon sequestration and its role in climate change mitigation. We wish to emphasize a global call to strengthen national soil information systems action through coordination and harmonization. And we are of the view that fair principles would be put in place to ensure data sharing that will be relevant to the consortium members and to the Society and to Ghana as a whole. On this note, we wish you a successful first EJPC arouNd project workshop in Ghana. God bless you.
Maybe I should make a rule that until the person sits down, we shouldn't stop clapping. Please do better. Thank you, thank you, thank you. Okay, so thank you so much, Dr. Yeboah, for the comprehensive overview of what your society is doing to enhance this conversation and this initiative. We are taking one last speech from another stakeholder, and this one is coming from the representative for the principal investigator of the EJP arouNd project, and he's in the person of Dr. Abad Shabi. Please appreciate him as he comes. And he is from Inrai, France. Okay, so he's doing a little, one or two things to be able to connect and project exactly what he wants to talk about, so that we follow by reading on the screen. Okay, so while waiting for Dr. Abad Shabi, we would want to take a word, while waiting for him to put everything together, we would want to take a word from a representative of the NCA, National Communications Authority. Please appreciate her as she comes.
Good morning, ladies and gentlemen. I am Diana Owusu-Ansah, the Regional Manager for National Communications Authority, Ashanti Region. And today I'm representing my Director General, Reverend Engineer Fianco. And so permit me to read his speech, standing on the existing protocols. Thank you very much for the opportunity to address this esteemed gathering of international researchers, policymakers, and innovators. As the Director of the National Communications Authority, I stand before you with both pride and challenge. Pride in our evolving communication ecosystem in Ghana, and a challenge in aligning that ecosystem with the kind of data-rich, connected environment that underpin modern regenerative solutions, such as those that we will explore this week. Our authority, which was established under the NCA Act 769/2008, is mandated to license and regulate electronic communication activities and services in the country. Our mission is clear: to regulate the communication industry in a forward-looking and transparent manner, to promote fair competition, stimulate innovation, encourage investment, and facilitate universal access to quality communication service for national development. In the context of this workshop, focused on soil carbon, greenhouse gases, and regenerative practices, the role of communications and data systems may at first appear peripheral. However, I assert firmly, communication infrastructure is foundational. Our capacity to monitor, to sense, to transmit, and to integrate is what enables real-time decision-making in landscapes, farms, and communities. Consider the example of on-site sensors measuring soil carbon fluxes, or remote networks tracking greenhouse gas emissions across agro-ecosystems. These systems rely on robust connectivity, spectrum availability, data security, and operator licensing. All of these fall under the regulatory oversight of the NCA. Therefore, today, I wish to highlight 3 key areas where the NCA's mandate aligns with the regenerative agenda you are advancing today. 1, connectivity as an enabler of real-time measurement. The sensors deployed in soil profiles, drone flying above regenerative zones, and field stations transmitting data to a cloud database or rely on the communication backbone we regulate. Ensuring that remote rural areas in Ghana are connected and that spectrum is efficiently allocated and interference-free is critical. In doing so, the NCA supports a smart land management paradigm. 2, data integrity and innovation-friendly regulation. As you develop methods to monitor carbon storage and emissions, digital measurement, reporting and verification platforms, and predictive analytics, regulatory clarity is vital. The NCA works to ensure that operators are licensed, standards are met, and innovations can scale without regulatory bottlenecks. By stimulating investment in communications infrastructure in rural context, we can help make digital soil carbon technologies viable. 3, inclusive access and rural impact. Universal access to quality communication services is not simply a tech target. It is a development strategy. For regenerative systems to benefit smallholders, youth networks, and community-based sensors, the regulatory environment must support affordable and reliable access. The NCA is committed to leveraging its mandate so that the benefits of data-driven soil carbon and GHG management reach all segments of society, not just well-resourced actors. In closing, let me emphasize this quote: data is the new soil. Without connectivity, it cannot bear fruit. As we meet this week, I encourage you to think beyond the farm gate. Think about how your methods, your sensor networks, your data platforms and models will communicate, how they will connect, and how they will scale. The signals that rise from soil pits must travel to dashboards. The insights produced in Kumasi here must reach the villages. And the innovations in Europe must link with practices in Ghana. The communication piece is no longer an option, it is integral. On behalf of the NCA, I pledge our support in creating a regulatory environment that is responsive, innovation-friendly, and inclusive in the regenerative future you are shaping. Thank you for your time, and I wish you a stimulating and productive workshop in Kumasi. Thank you.
She hasn't sat down. Please continue. Okay, thank you so much, Director NCA. And at this point, we are going to take the speech from Dr. Ashat Shabi. And you would have to do the projection. So kindly give us a minute while we put it together. Okay, so we are still trying to put it together, but while at it, you can see from the screen, we have the password of the Wi-Fi. Can you please project it once again so that members can put it down and connect? I'm sure it'll be back very soon. So once it's back, I'll prompt you so that you connect to our internet. Okay, so we are having 1 or 2 challenges, which will be resolved very soon. But then on the schedule, after this, we are supposed to take a group picture so that we keep memories for this wonderful moment. And so while we are waiting, I think it would be ideal we do that now. And also owing to the fact that there's academic board meeting going on and the representative for the Vice Chancellor and IPO would have to be there. And so please, let's follow the lead of the ashes and go outside and take a wonderful picture for posterity and for good memories. I'm tempted to say that clap for yourself, but I mean. Okay, so you're welcome back, and yeah, I hope you stretched alongside. Okay, so Dr. Shabi is here, and his presentation is finally ready. But before he goes on, like I said earlier, before we stepped out, kindly see on the side. Oh dear. Just when I was about to talk about the Wi-Fi connection, it's been overridden again. But it will be back, so Dr. Shabi, please go ahead. Please appreciate him as he does that for us.
Okay, good morning, everybody. So I'm very pleased to be here, and it is all the meantime, it's a very surprised to give this presentation because it was not in the program. So everything had to be managed, and then Melissa also, she's not here, so anyway. So I can give you an overview about the EJP Soil and the context, how this project has been built. As you can see from the first slide, we, in the past, I think 2-3 years, I think that was 8 new European joint program in soil projects has been also included in this program, which is represents basically 30 or 63 new partner. And the main objective of this project is that to basically to strengthen the soil restorations practices in the context of intensification across Europe, but not only across Europe, but also worldwide. And as this project is also highlighting, managing soil in the context of climate change, because everything is connected to context change, because we have not only land use and intensification, but we are in the context of climate change, but also developed innovative method of sensing technology, specifically some of the practices that need to be assessed and to follow and record. And then when I'm talking about that, it's basically on carbon stock. So we need to find a way on how to find cheaper way, but also efficient way to monitor the carbon stock locally, but also internationally. So this is, this project is part of the international concept, and then basically it is part of the topic B, which is managing soil in the context of climate change, understanding impact of carbon, nitrogen, and phosphorus cycling and greenhouse gas emission, and removal using data derived from the long-term experimental sites, but also benchmark farming. It involved also 12 countries from around the world. It was mentioned in the beginning of this presentation today, this morning, basically from Brazil, France, Norway, Uruguay, South Africa, Canada, Namibia, Ghana, Estonia, and Hungary, New Zealand, and Germany. So this is a really various set of sites, but also set of country with the experience, but also for a lot of discovery. So this project standard for 36 months. It started on May 23, and then will end the next year, 2010. We are extending, and it will be a discussion on how we are going to move on for another year without any extra money, because it is very important to extend the project as far we still have some money, but we're also reaching a kind of, let's say, data. These data need to be processed. It will be a pity if we end the project on May without finalizing the whole objective that we have promised during this project. So this is the coordination. The main coordination is from Embrapa, and I'm just vice coordinator in this project. Just to, it was the institution that are, you can see here, involved in this project. This is also reflecting the countries, and that's very well experienced, but also not only in agriculture, but also with respect to climate change management and all of these things. What are the main questions? So this is a very ambitious project that I think that is a 3 years project or 4 years. It is not enough, but I think it was also it was understandable from the funding agency that we are not going to produce all of what is here and to respond to the data that's able to respond to this question, and the way basically coming from increasing the agriculture practices that are most effective in increasing carbon stock. That means what are the agriculture practices that's able to increase the carbon stocks and at what rates, but this is also here is a matter of discussion because we need not to focus only on carbon stock, but also to keep an eye on other greenhouse gases because increasing carbon stock without keeping an eye on greenhouse gas emissions, that doesn't make sense. So we have to have a combined effect while reducing, but also reducing greenhouse gas but and also increasing carbon stock. So this is two ways on how these two components are linked to each other. The microbiome, I think that the microbiome is very important. You're not saying my slide. I'm talking in the sky. I didn't touch anything. The first objective, which is this, and this is how we call two ways on how to increase the carbon stock, but also we have to keep an eye on greenhouse gas emissions. So this is really a very two components that are closely connected. The microbiome, that is very important. There's been a lot of discussion in the literature, but also in the past and still ongoing things. So at what extent the all intensification management affecting the microbiome, which is not, when I talk about the microbiome, we have to keep an eye not only on micro, but also in soil fauna, which are intimately also doing a big role on carbon, but also on nitrogen, and then also on the stock humidity itself. So how these managements are affecting these things and at what, which consequences. And then the nutrient, when we talk about the carbon, we have to also to keep in mind that also increasing the nutrient, and because it is they are completely linked, so it is disappearing again. And then yes, it happened. So we have, you see, we have the increase on the practices that also push the carbon stocks. We have the microbe, and then we have the nutrients. So this is something that we need to manage. But in the meantime, there is no, how we call a magic recipe. You do something, but you have the side effect of the practices that you are doing. So you would never have at the best component that your system is perfectly 100% sufficient. So you need to manage your trade-off. And trade-off that are between the carbon stocks, carbon sequestration and greenhouse emission. This is very important. We have had two PhD students once within the framework of 4-per-mil initiative, because it's one of the big discussions going on. That's at what extent you increase the carbon stock, but also increasing carbon stock, you reduce carbon dioxide from the atmosphere, which is a good thing. But in the meantime, with this carbon stock that you are increasing is also not turn out to release nitrogen oxide emission, which is has a devastating effect on climate change, specifically the warming potential, which is 300 times higher than the CO2. And we have some of the results showing that, of course, there is no close correlation between the increase of carbon stock and nitrogen oxide emission, but the problem is depend on the quality and the quantity of the carbon you have in this system. This is very important if you have how we call organic carbon, which is basically constituted of labile compound, then you stimulate the greenhouse gas emission in the system. So there is a kind of combination that you have to keep an eye on it and make sure that your quality and quantity of carbon you have in the system, based on the management that you are doing, you have to assess at how much of this nitrogen oxide emission is going to the atmosphere. This is very important in terms of this trade-off, because also you have the stoichiometry itself is changing, CNP, so you have to also to combine all of these things together, and you have to have the whole picture how these things are interacting to each other. The climate, of course, it is also another. You manage, but we are in the middle of the climate change. There is no way to avoid it. We have to deal with it, and we have to manage our system based from what we have on the top, which is climate change. What are the consequences of extreme climate change, specifically the extreme events? Some of this side, they didn't have rain for years. Now they have intensive rain or extensive or extreme drought. So this system is responding differently from what are the duplication, repetitivity of this extreme event in the system. So need to be captured from the side. And then, of course, we need to develop what we call the indicators of the best practices, which is, for me, is a big word, because we can assess some of them, but for me, the list can be very, very long, and then you have to select the ones that are more responding to the management that you are inducing in the system. So, no, it is not. What? It's okay. So this is to give you the context on how this thing. But what are the main objectives of this arouNd? And you can see that the project itself, arouNd, represents a kind of exploratory effort to couple, because I told you 3 years you cannot do everything, so you have to start from what is already available and then build on this what we have what we promote in this project. So this is an exploratory effort to couple the stoichiometry driver to microbial populations related to carbon, nitrogen, and phosphorus cycling, and stock and greenhouse emission and the drivers, diverse agriculture practices. We have also at each of the site, we have 37 field sites with different chronoseconds or contrasting agriculture management, in which 26 established for at least 10 years. So this was a kind of promise when we selected this site, that the site we should not start from scratch, but at least have some historical data in a way that we can build on the top, but also adjusting, coming with the new data in a way that we can strengthen the model, but also test the model and then validate the model. So at each of the sites, we can estimate the scenario, modeling of possible emission, for example, nitrogen oxide, CO2, and methane, from the cropping, pasture, and forest system, because we have basically most of the land use, forest, crops, and pasture, and then try to assess this based what we call here the IPCC or local emission factors, that just make a simplistic model from what IPCC has been done to calculate how much of this carbon or greenhouse gases emitted based on this emission factor that what's developed within the IPCC program. So what is the approach? As I said in the beginning, we don't have time short, and then we will also start from what we have already in the system. That means this project, and I have to be very clear on that the project will build on a worldwide database. This is very important, of the carbon nitrogen stock that already exists in all of these different countries, but also in the different sites that's been proposed in this project, which means carbon nitrogen, bulk density, soil fertility, greenhouse gas if it's available, ecosystem under differentiation agriculture. And then, of course, furthermore, that the project will determine at what event extent of climatic condition we can evaluate the net primary production of the cropping system and soil types, effect on sea and N stock, nutrients, and then, of course, greenhouse gas emission. And the final product of the project will be to build, recommend best management practices, I mean, for farmers, but also for stakeholder and policymaker. This is what we sold in this project, and then what we are committed to deliver at the end of this project. And you see here, we have a very nice map worldwide, in which we are covering basically all of sites. And the most tricky thing sometimes in the beginning, when you start writing the project, they can add the points and on different sites, but when it comes to collecting the data, it's another story. It's another story, another big fight. It doesn't mean that this data doesn't exist. It exists, but you have to put it in an available way, but in a available format, in a way that it can be used easily. And sometimes it can take weeks, even months and years to put all of these data together. So this is where we are, and I think this is very important. If we can extend the project for another year, it will make really this project a very successful project. So how this thing will work, and what are the philosophy of this project? We have the site that from North America. We have 2 sites in North America. We have basically, let's say, 90 sites from South America, basically most of them from Uruguay and Brazil. We have 9 sites in Europe, and then we have 6 sites in Africa. And in Australia, my colleague David Whitehouse is here, and then they have a long set of the data. Also, all of the data, they have to be shared out to a database. It can be calculated or raw data, and this data should be treated or managed or how we call accurately in work package 1 and work package 2, which are at times connected to the work package 3, and in a way that we can provide not also for the modeling exercise, but also for providing some of the scenario and some of the how we call the best practices and how these things are moving in a way that we can convey this information to the stakeholder and farmers. So, of course, for every project we have to, this is a very important component, what are the impact of this project? And I think that is why this project has been selected for a very competitive. Why? Because it was not only covering a worldwide, but also it's trying to explore some of the area that never have been explored, but also to make this data also playing a role in the modeling exercise. So the first thing which has been looking for the funding agency is that creates a global data set, which is very important as much as you are trying to have a philosophy to build a database and also covering the sites that are not yet covered. And you know, all of this is not a criticized. We are missing and we are lacking data from the African continent. So we have only few data from the African continent. And of these data specifically on carbon stock, specifically on greenhouse gas emissions, specifically on management. So when we build these global models, So we try with 1 point sometimes and 2 points, try to exploit what's going on in Africa or which is completely not really without huge uncertainties. So as far we are building this data and increasing this data in this continent, we will make this project or the modeling assessment and the projection more strong and more efficient, not only for providing and advising the, how we call the best management practice, but also in the context of climate change and, as you know, really, and an increasing population in which we put the soil and the resources and the trees. The second thing it is determined to what extent climatic conditions have been talking about and how they move up, because we know all of these things will not respond in the same manner. We have what we call the region-specific, not the whole continent will respond the same, similarly to all the climate, but also region-specific, and the region-specific, it depends on the management. And this is the thing that we need to deepen and need to look more in detail at what extent this regionality in the system of a country or a part of the country is influencing all of these things. And of course, least not is to provide the best management practices. So this is how we call this project, as I said, will build on a worldwide data set on carbon, nitrogen, and bulk density and all of these things. And then we need this data, and I hope that this data can be made available as soon as possible in a way that if we extend the project, we will be ready to run some of these scenarios and then provide some of the things that we provide to do it. That's it. If you have any urgent question, but we will have the whole week to discuss all these things. Okay?
Doc just took us to the classroom, and there were lots of things, and I'm sure you wrote some things down. And so if you have some questions, you can ask, and he would answer. Please, do you have any questions here? Okay. Please appreciate Doctor. That was a very extensive one. Even with a very short notice, he gave us a very wonderful one. Dr. Shabi, thank you so much. At this point, I think we've been sitting for so long, and I'm even struggling to get you to clap, and so I know that we need to get some food, and so we would want to take a coffee break. We should be back in like 30 minutes. So please, you just go outside. You see a canopy over there, outside the hall, I mean. Sorry, and there's a shade outside there. On my right, when you go there, there's variety, and so you're going to be served whatever you desire to eat this morning. And so please, shall we go, because you have just 30 minutes to come back and continue with the panel discussions. Please appreciate yourself for staying through all the speeches and listening to our stakeholders. Thank you. Thank you so much. So we'll be back. Thank you. Good morning once again, and welcome back from that needed break. And we are zooming in, but before then, during the break, I received a couple of concerns regarding the Wi-Fi password. So you may be having a problem connecting because you probably chose syndicate instead of syndicate Wi-Fi, syndicate_Wi-Fi. So before you choose the name of the connection, make sure it's syndicate_Wi-Fi instead of just syndicate. If you choose just syndicate, the password wouldn't work for you. So kindly note that you are still having a challenge even with that. None of them is available. Oh, okay, so it's just syndicate appearing instead of syndicate underscore Wi-Fi. All right, I'll report it to the technical team, and I'm sure they would. Sorry? Okay, so you can also equally look for control room and use the same password. Hopefully that works. Control room. All of them. So all of them would give you... So I'm giving a moment for us to try and connect. This is working? Okay, thank you. Let me add about 2 minutes so that we try and... Is it working? It is now? Okay, so we can move on, I'm sure. Is it working? Finally, everybody is giving a positive answer, and so I'm sure we can move on. So at this point, we want to take a conversation on how far this project has come, what we've done so far, and I'm sure this is going to inform us to see how the conversation will go on going forward. And so we are going to be having work projects, 1, 2, and 3, and each of them is going to give us about 15 minutes. And I'll reiterate that whilst they are at it, we do well to put down some notes and all that, because it's going to direct the discourse going forward. Thank you. So the first one is going to be done on standardization protocols for data collection and harmonization. And to do that for us is Professor Vincent Loga. Please appreciate him as he comes.
Okay, thank you very much. So I'm presenting on behalf of the entire work package 1. It's a team of scientists across the globe. So I want to show some of the outline for the presentation. I'm going to look at the overall project aim as also iterated by Abad, my senior colleagues. We're always meeting online, but today we are meeting face-to-face. But I remember we met at Soil Organic Matter in Göttingen, where you did a lot of teaching on soil carbon fractionation. Great. So we'll look at the concept of regenerative agriculture, and then I will also look at the aims of the work package 1, and then show you the team composition. Then I will take you through some of the activities, progress, and some key outputs or deliverable, and I would like to also draw some few conclusions. So when we talk about regenerative agriculture, it focuses on the farming that focuses on restoring soil health. If you don't restore soil health, you are not doing regenerative agriculture. And then whilst you are restoring soil health, we are also interested in ensuring biodiversity and then improving ecosystem services such as soil carbon sequestration. And overall, you are looking at sustainably enhancing agriculture so that you can feed your current population whilst also ensuring that the resource base of your system is robust for the future generation. That is all about sustainability. We can get all that we need now, but if we are not aiming at sustainability, it means that the generation that comes after us will have a bone to tackle with. So these are all the 4 pillars of regenerative agriculture. So for the EJP project, it's among 13 partner institutions across the globe. And the aim is to refine soil conservation and regenerative practices. And in doing that, we are looking at to enhance soil carbon sequestration and at the same time reduce greenhouse gas emissions from our farming system. So any farming system that reduces greenhouse gas emission is climate smart and is also regenerative as well. So for the work package 1, it's a team which I led, and then we look at standardizing protocol for the entire consortium so that nobody is doing carbon workly black while others are doing carbon dry combustion. So we want to be on the same page so that we can model and compare results. So the aim was to generate new data using these protocols, these harmonized protocols. And before we generate new data, we also want to look at what data is there already that we can follow on. So we have long-term experimental data that we have across all the institutions. So one of the key requirements of the project is that you should have a long-term field that you are working on, that you have data, that you have run using your own protocol. But in the harmonized EJP, we want to do things common so we can compare. All right, so this is among 13 partner institutions. So for the work package 1, I happen to be the lead, and we have Beata from Embrapa, Abad Shabi from INRAI, France, Herman from Germany, Claudia Edward Yeboah from Soil Research Institute, Caleb, Thomas Oliveira, and others, as you can see, with the different logos. So we had a number of online meetings, okay? And then in these online meetings, we discussed field sampling protocol because we wanted to get things right from the field, get things right in the laboratory, so we look at sampling depth. We agree on a number of sampling depth for the consortium, and then we have a harmonized, source profile P description. And then, of course, we also measured greenhouse gases from some of this field. So we did a number of work which is around carbon fractionation, and then we look at the granulometric method. Let me sip some water before we move on. Here we had a lot of debate. We have some colleagues saying that why can't we do density fractionation? Some say, why can't we do size fractionation? But we realize that size fractionation is what is used in so many soil carbon models. So it is good we do current science. So we look at the granulometric method, where we have fractionation in 2 pools, the particulate pool and also the mineral-associated pool. And then we did also a very novel work where we look at the composition of soil organic carbon in the laboratory over a 98-day period. So you monitor, and you also quantify how much carbon dioxide is emitted within these phases. It's a very laborious work. And then we also do soil-specific area, because we all agree that before you can store carbon, then you must have a large soil surface area. Because if you have a soil with large surface area, you're going to store more carbon than a soil with very low surface area. So we measured soil-specific area, which is not mostly reported in literature, using Kirschbaum and others protocol. And then for the exchangeable cations, we agree that we can use EDTA to do the extraction, and then those who want to use ICP can do. Those who want to use, flame photometry for the exchangeable potassium and sodium can also do. But for ICP, we all agree that it is not so sensitive for, doing exchangeable calcium, exchangeable potassium and sodium. So we decided to use flame photometry for potassium and sodium. So in terms of the historical data, it has been a tug of war working with a very large team. So we still have some partners who are yet to deposit their data in the Zenode repository. But I'm glad to say KUSC have done that, CSR, KUSC have done that long ago. And then we are also pleading for our partners to still do that as we move along. And then also for the new data that we are collecting, it is almost 90% true for the partner institutions. These are the new data we are collecting using the harmonized protocol, and we have over 90% completed across the consortium. So for KUST, we have 5 postgraduate students who are supported by this project. The PhDs are receiving stipend, and then we are supporting the research work, field and laboratory of the master's students who are 3. And we were very mindful of gender balance, so we forced in a lady so that we don't have all male throughout. We also supported 7 undergraduate students who have completed. We supported their field and laboratory work as well. And there is a PhD also in Germany. As you can see, Johanna there, she's a PhD student from Germany. She's also working on her thesis as we talk now. And I'm aware there is two masters who have completed their research work currently in South Africa. That is a very good plus. In Ghana, one of our masters who have done the submission, and we are yet reviewing his thesis for submission. Thank you very much. So let me brief you through some of the project outcomes in terms of papers, in terms of scientific meetings and others across the globe. So we have 6 journal articles. I might say that 3 of these are already published by RTPU in Germany. KUST, we have 1 paper published, and then 1 in review, others in progress. We have 5 posters. We attended 6 conferences, and we also participated in 2 other meetings, which are mostly stakeholder meetings across the globe. So for KNUST, our first paper was published in Soil User Management recently. That was about 1 week ago. We have one which is compiled by Emmanuel Bedu as a review paper on the drivers of soil organic carbon stocks in sub-Saharan Africa, which is under review in Helion, and all other manuscripts are in progress. I believe as I'm talking, the students are here doing when they will have their own papers submitted later for review. Okay, so Germany, a paper was published this weekend, as I was told, and other manuscripts are also in progress. For South Africa, they have published a paper in Soil and Tillage Research, a very renowned soil science research journal that we know, and 2 other manuscripts under review in Pedosphere and also in Helion, a very good update from Germany. Hungary did 3 posters. One of them was presented at the biennial meeting of the Hungarian Social Society in Godolo, very nice city to go. And of course, there was another one too presented at the Eurosoil in 2025. That was the second poster. Hungary also did another poster, which was presented at the Hungarian Academy of Sciences in September 2025. Estonia did a poster, which was on effect of long-term fertilization on crop rotation, on soil physical, chemical, and biological properties. So for Ghana, we attended a number of scientific meetings across the globe. In January 2025, I was invited by the German Federal Ministry of Food and Agriculture as an expert panelist on soil carbon sequestration at the Global Forum for Food and Agriculture in Berlin. That was a very high panel discussion, and I participated that with David Whitefield's student, Max Anelli, in Berlin. And then I also did a presentation on the joint agri-dance project between Germany and New Zealand. It was a webinar in September, few weeks ago. And also, I also participated in a very dialogue meeting in the University of Bonn in Germany, where we are putting together a new proposal to look at land surface modeling. And this is something new we are pushing up. And part of this data was presented in this project. And then my own mentee, he finished the PhD long ago. Caleb also presented a paper in Bulgaria. And then Emmanuel Bedu presented a paper at Soil Organic Matter in UMCSP Morocco in 2024. And then we did a local poster at the KNUST 70th anniversary celebration in 2023. So Estonia did a paper which was at a conference meeting. And also, they also participated in the Eurosoil 2025, as you can see in the links there. New Zealand made a number of public presentations with stakeholders. One was the Global Research Alliance, which I also participated, but mine was overnight, so I had to stay overnight. And then at a point, I thought maybe my time had elapsed because I dozed off a little bit. Waking up around 2 a.m. to do my video presentation. So these are some of the meetings that New Zealand, represented by David, did across the period. So for KNUST, the 2 PADs, you can see Joshua sampling in snow in Norway in December, very cold climate. And he brought the samples back to Ghana. We got him certification from the Ghana Geological Survey Department, and he has done a lot of work. And his work was also funded by France, led by Abad and also Cornelia. You see Manuel Bedu on field sampling in Asantequa in Kintampo. And these are some of his African dark earth sites where you see very thick horizon, very dark soils, which are really, really anthropogenic. So you can see these African dark earth were actually created by the activities of the indigenes. Okay, as they put kitchen waste around their household, the soil gets improved with time. You can see it's a very dark soil. Even without fertilizer application, you see good yield, as you can see. And also, this is some of the soil that we got from New Bonfire here. And maize yield was good on some of these soils. So I want to present some key results from the work by athletes in Ghana. So we look at soil carbon stock across the African dark earth, and then the non-African dark earth. Okay, we estimated for gravel using the FAO protocol, and then you can also see that along the African dark earth, soil carbon stock was very, very high, apart from the others which are quite low, which are non-African dark earth. So we also wanted to look at how much of the bulk soil carbon is stabilized in the different pools. If you have bulk soil carbon, which is so much, but you have much of it in the particulate pool, you are not going to store carbon in the long term, because you all agree that carbon, which is stored in the particulate pool, takes a very short time in terms of resident time, mostly up to 10 years if you are lucky. But if you store carbon in the mineral-associated pool, it can take up to millennia, as stand to be debated, but that's what the literature says. Several hundreds of years, up to millennia. So we look at carbon stabilized in these various fractions. And then we saw a very interesting trend that if you look at the surface soil, the 0 to 10, 10 to 20, the non-African dark earth are stabilizing carbon more in the persistent pool. But if you go to a deeper depth of 20 to 30, you see that the carbon stabilization in the mineral-associated pool in this African dark earth is more. So it is something quite interesting. And then we're doing a lot of modeling to look at the drivers of persistence of soil carbon in the African dark earth. But generally, more of the carbon is stored in the mineral-associated pool, as we know across the globe. This averaging around 75% and above in the mineral-associated pool, whereas 30% is to the particulate pool. So Joshua did a very interesting work from the long-term experiment in Nibio. Here, he wanted to look at specific surface area of the soil vis-a-vis carbon stock. So it is clear, you can see that where you have a very high surface area, if the soil has higher surface area, it is able to store more carbon. And it is just very, very important. But we only determine this specific surface area using dry weight. Okay, we did the air drying the soil, and then moving on to oven dry the soil. And we use a very nice relationship to get the specific surface area, and it's a very novelty in this work. So in Ghana, I'm focusing on Ghana more because we are hosting the workshop, but all the updates I got from the partner institutions to have duly been presented, as you can see. So we did a community outreach program in the northern part of Ghana involving 126 farmers. We trained these farmers on organic carbon and soil fertility management on their farms, teaching them how to prepare compost using recalcitrant plant material to be able to store carbon in the persistent pool and also carbon in the particulate pool. And we also supported a community carbon outreach program. We procured seedlings, tree seedlings from Forestry Research Institute of Ghana, and then we supported the Nkranza community to plant these 10-acre trees so we can support their carbon offset programs at the local level. The chief sent me some photos recently, and I saw that he was very, very excited that the trees have really, really established. That is the joy of it in terms of community outreach. So I'm not concluding based on the science, but I'm concluding based on the progress of the consortium. So overall, the consortium is on track, even though we still have a lot of issues working, in big, it's really, really challenging, but of course, we are on course. And then we are achieving all deliverables as we plan, but we are hoping to extend for 1 year at no cost extension. And each institution has to seek approval from its funder. Ghana, for instance, we are being funded by the Ministry for Primary Industry in New Zealand. They are funding our work, while others too are being funded by different stakeholders, but under the same EJP Soil program. So, of course, the PhDs and the MPhils are on track. I know they are really doing well, writing and then trying to produce manuscripts which are very scientifically sound. So I know some may be joining online. Some of our international partners may be joining online. I want to appeal that those who are yet to bring in their data into the repository should do that. Should please do so, because we need to upload the old historical data and also the new data as well. So we use this opportunity to solicit for this very important data. So I want to acknowledge all these funding institutions, EJP Soil, Global Research Alliance, and then, of course, our funder, which is the Ministry for Primary Industry New Zealand, to support the objectives of the Global Research Alliance as they fund our work in Ghana. And I also want to thank all of you for granting audience. I know there will be a lot of science sessions that you will take more cue than the update, but this is also more or less throwing some few light on what you have done as a consortium. So these are some of the key references, and I want to thank you very, very much. Thank you.
Please appreciate Professor for keeping the consortium on track. Thank you so much for the good work you are doing. So we are going to the second one, and that is going to be given by Dr. David Whitehead. Please appreciate him. Drivers of soil carbon stabilization and vulnerability. Appreciate him. Please, you can do better.
Well, good morning, and thank you for hosting us for this wonderful opportunity to discuss our progress. We've had an amazing overview of Work Package 1. Thank you very much for that, Vincent. But I cannot, unfortunately, give you anything like the depth of overview for Work Package 2, simply because it is really only just starting. And we have a plan of how it's going to work, but this year is going to be critical for the achievements through Work Package 2. So we're all aware of the data that are available, and Vincent has asked us to continue making those data available for the database. But in terms of using those data, and bringing them together, harmonizing is the word that we use these days, to bring the data together. That is the critical focus of Work Package 2. And of course, it's a very complex issue because we've tried to unify the way that people have taken the measurements using the approaches that Vincent referred to. We've tried to organize the data in the same way in terms of the variables that are needed to address. But we need to use models in order to bring these data together to estimate what the impacts are going to be. So we're all aware that there are differences in soil carbon stocks between different land uses and different management practices. And for a long time, people have been trying to ask, why is that? What are the drivers? What are the constraints? What are the vulnerabilities? It's a very, very complex question. But the point of this project was to bring together a much larger group of data from a lot more experiments across the globe to have a much firmer database in order to address these issues. And that's what we're attempting to do. So, of course, there is the issue of the questions around what are we trying to do. Why are the differences in carbon stocks? And how are they changing in relation to land use? So we're proposing there are two approaches to this, which will work together, they'll work collaboratively. One approach, which is rather the inductive approach, is to take all of these data and use a statistical model in order to relate the carbon stocks to different variables, whether they're climatic, edaphic, historical, management variables. And we will do this using a statistical approach. People have done this, there are people who have done meta-analysis in this area, but there's much less been done in terms of being able to use a statistical approach. And we will use as many of the data from the different sites as possible to bring together this statistical approach. However, that doesn't really answer the question, why? Why are the differences in carbon stocks? And in order to do that, we have to use process-based models where they have a much higher demand for data, much higher quality of data is required, and they are specific, particularly to one site. So in order to do that, we will select a small number of key sites where we will do this process-based modeling. It is not possible for us in this project to do process-based modeling across all of the data sets. We will focus on that particularly. So as I mentioned, we're just in the process of starting that data. What do we expect to come out of it? What are the outputs going to be? Well, they will be indicators of why there are differences in soil carbon stocks. There will be indicators of the vulnerability of those soil carbon stocks to loss. And I'll talk more tomorrow about that in relation to the work that we've been doing in New Zealand. And more important, this modeling will allow us to run scenarios, because we're all interested in scenarios about what if we were to change the management practice? What would the impact be on those soil carbon stocks? And secondly, of course, the overwhelming need is to look at the scenarios for future climate change, because they are going to impact everything in relation to the regulators, the controllers of those soil carbon stocks. So I will leave that there for the moment with the conclusion that we are starting this. We are confident that we can make good progress. But when we meet next, and I hope there will be a subsequent meeting as we come nearer to the end of this program, we'll have much more to show you in terms of what we have achieved during that time. Thank you.
I thought we agreed that until he sits down, we won't stop clapping. Thank you, Dr. Whitehead. Thank you so much. So we are taking the third work package, and that is on networking, knowledge sharing, and communication, lessons from work packages. And that's being given by Dr. Caleb Melenya Okansi. Please appreciate him.
Good afternoon to you all. I'm going to wait for the presentation to be set up, but networking for our group started quite early. I remembered I was sitting in the office one day. By then I was doing my Erasmus exchange in Hungary, I think in 2022. And I was called, there's a project coming, which is on the European Joint Project. Are you interested to take part? And I was like, definitely a yes. And then the head of the institute indicated, are there some partners in Ghana whom you want to include into the project? Then I was like, we have 2 Erasmus visitors coming already. That is Dr. Edward Yeboah, who is currently the president for the Soil Science Society of Ghana, and then Professor Vincent Loga, who I would say supervised me within my PhD. So luckily, we were able to form a 3-man team from Ghana, and so far, I'm not boasting, but I would say Ghana is doing very, very well within the EJP program. So our place is So I'm going to go very fast when it comes to the knowledge sharing, social media, and then scientific communication with both the players and then the non-scientific stakeholders. So far, there are 2 key things we will need to do as a group. And then from what David said, we will need to get to harmonizing the data first and getting some interesting results for us to be able to do the technical publication. So that part is also still at the initial stage. But on Wednesday, we are going to sit down as a team and a group to come out with the framework for the technical paper. And then we will also come out with an executive resume. And that one will constitute a lot of the nice time, the podcast and then nice events we are holding as a group. And then David suggested or talked about a final meeting. And then it is also part of the WP3, where we'll be doing a final global workshop, where we are hoping that probably in about 1.5 years from now, we should be completed with that, and then we'll have a whole lot of data to show. Something like the project logo, website, and almost all the social media pages had already been done. Part of the WP3 activity is to reduce risk. So partly, almost every month, we hold a meeting, and then we discuss activities. And through that, we've been able to learn a whole lot from what each partner is doing. And hopefully, we will get an update on the digital activity each partner is doing tomorrow. So the first draft of our technical review is expected 1 year from now. And then we have some people who are going to work around that, which are myself, Adonis, who is from South Africa, and then Marcia from Brazil. And then the first draft of the executive resume will be done by Melissa, who is the PI for this particular project. She wishes to be here, but on the final last 2 days, the flight was canceled. Now, for most of the WP3 packages, the Ghanaian team, or the workshop in Ghana here, is going to help us to complete about 60% of our activity, meaning that the field day events with local stakeholders and farmers will be done on Thursday. And then part of our activities is also to engage with a lot of the next generation of scientists. So on Wednesday, we are going to meet a lot of postgraduate students who will come and present their findings around our subject matter, that is carbon storage and then emissions. Now, there are 2 things which are going to be key till we complete our program, which is the final global workshop, which will be decided by the whole team, especially by Abad and then Melissa. And then they will also help us to define the agenda for that particular workshop. So I've already talked about these things that they are already done. So this workshop in Ghana is very, very key. It has enabled, as I said, us to complete about 60 to 70% of our tasks. And then Adonis will help us to do a lot of the podcast, which is under the WP3, meaning that he will need to get to know what each partner is doing and put it on a record. That is on a podcast, which will go onto our web pages. The field day is coming on Thursday and then on Friday. And then the key stakeholders engagement, part of it had already been done in Ghana with the Ministry of Agriculture, the National Communication Authority, even the president of the Soil Science Society of Ghana representing. And then the engagement with the next generation of scientists are also underway, and we hope that we will complete 100% on Thursday and then on Friday. The 2 things which are going to be our next focus will be the executive resume and then the technical publications. Midase, thank you very much.
He hasn't sat down. No. Thank you, Dr. Okansi. Thank you. So at this point, I'm believing we've heard so much. We've been following through the speeches, the work packages and all there is. At this point, we would want to have a panel discussion where questions are asked, answers are given. In fact, detailed answers are given, and then your participation is also required. And so the technical team, please help me with some seats up here. And the panel is going to have a conversation on regenerative practices, on soil carbon storage, like Dr. Okansi just said, and greenhouse gas emissions. And we are going to have wonderful people. Some have spoken already, some haven't. We would have, I want to have the seats before I call them so that you know who is taking what seat, right? Thank you. Once again, I'm reminding us all that the washrooms can be found behind this hall. So you can use this exit or that, or even out there, there's a route you can use and get there. Or anybody out there, if you ask for the washroom, they will be able to assist you. I'm also hoping that at this point, all of us are connected to the Wi-Fi and it is working very well. Is it working? No? It's not? Oh, please, if you are not able to connect to the syndicate's Wi-Fi, look for control room. It's also not working. Oh. Dr. Adona, yours is working? Yours is working. Yeah, control room man is working. And it's fast and connected. Oh. Sorry. Okay, you can project the details of the router. That's okay. I think along the line, I'll give it to them to also put it out there so that anybody having challenges can connect to that instead. Okay, thank you so much for putting that together for me. So first on the bill, we'd have Professor Abigail Opoku-Mensah. Please appreciate her as she comes to take her seat. Professor Abigail Opoku-Mensah. Okay, we also have Dr. David Whitehead. Right, a seat for you. Please, until he sits down, don't stop clapping. That's also going to keep us very much alive. Thank you, thank you, thank you, thank you. Then Dr. Abad Chabi is also coming up stage. And then Professor Fred Nimo. Professor Fred Nimo. That's the Dean for Faculty of Agriculture, KNUST. Please appreciate him as he comes. Then we have Professor Eric Tutu Chow. He's in engineering in KNUST. And finally, we have Dr. Edward Yeboah. Dr. Edward Yeboah. Okay, so I hear he's having an interview outside, and he'll be joining in very soon. And to moderate this wonderful panel for us is going to be the Dr. Caleb Melinya Okansi. Please appreciate him as he comes also.
Please, let's wait for just about 2 to 3 minutes for Dr. Abad. Dr. Abad and Dr. Yeboah.
while waiting, I would entreat us all to try and get to know somebody. There's a whole salad of brainy scholars in the agri field. And I'm thinking that going forward, this conversation is really not going to end. And so if you get to know somebody, get a contact, you may never know when you might need their collaboration. And so while we are waiting, try and get to know somebody, pick a contact, make a friend. It starts from here, and it always ends well. Okay, so... Okay, all right. So I think you can go ahead so that we...
Hello. We've been talking a lot about carbon storage and then emission for almost the whole day. We're having now experts in the field who are going to guide us to understand the whole process far more better. So our first question will go to Abad. And the question is, what regenerative practices are consistent to store more carbon in temperate soils?
The best practices in helping to increase carbon stock. So honestly, it depends on the system where we are. I mean, as I said in my presentation, there is no magic recipe that can be applied to all systems and all of things, and it depends what we have. So if in temperate soil, I mean, we have now many discussions to reduce the tillage, to have multi-crop, to have the introduction of crop within grassland within crop rotation with different duration, to reduce the fertilizer, and to restitute the organics, and then it works in one place, maybe not in another place. So we have to, as we said in my presentation, also it depends on the site-specific and region-specific where you are applied. So you can't come with a picture that can be applied to every place and then said, okay, this is what you have to follow and all of this thing. So this is one important thing. So you have to adapt your management practices and depend on the resources you have in place, but also keep in eye. This is very important, and we forgot all the time, the farmers. The farmers, you cannot impose them something that goes against their expectation. And I told you their expectation in terms of production and gaining money, because they have to survive. Or it happens not quite often. This is also one of the mistakes that we can all the time. So we impose them some practices, but without compensation. Because if you want to have a time delay to see what happened for following this practice in terms of carbon stock and how much it's increased carbon stock, you need years, and then probably many, many years to see what's going on this system. And then in this time, the farmers need to survive. I mean, you have to have the compensation to do that. And another thing which is very important, that the farmers, they have, at least I don't know in Africa, but I think in Europe, they have to follow the market, the demand. So sometimes they know very well that such practice may be worse for their system, but they do it because there is a market behind, because a production behind, because they can learn money, they can earn money behind. So this is something that needs to be adjustable, and farmers, we can leave them in a jungle, and impose them some practices they don't like to do, but also if we want to, that they can do it, they need the support, they need subsidize, they need help from the stakeholder to follow this thing. So I think it is, the best practices is a big word, but in reality, it depends how you manage these things. Yeah.
Thank you very much, Abad. Similar question goes to Dr. Edward Yeboah. In the tropical system, do we have some key parameters or drivers which we think drives our carbon permanent storage in our systems?
Thank you very much for the question. Yes, in tropical ecosystems, there are established practices that really drive the soil carbon storage. We have come to understand that, yes, there are sinks and there are sources of carbon in managing the soil. If you look at the sources of carbon in the soil, or the gases that we have, unsustainable soil management practices are all the things that leads to the greenhouse gases that we find. Alternatively, we also have sustainable management practices that are able to store carbon in the soils and improve soil carbon sequestration. We've come to understand that, yes, there are good sustainable soil management practices that are able to help with the food security as well as reducing the greenhouse gases emission. And that is where we need to focus on, because we need the food. We need the food to feed the people. We do not store carbon for the sake of storing carbon. The carbon needs to be stored to ensure that we provide food for the people and at the same time be able to reduce the greenhouse gases emissions. So we have come to find out that there are compost management practices that can be used to improve on the soil organic matter content in the soil. And then also management practices that can also help improve on the storage. And that is what we are focusing on. Within the EJP project, we have also identified the African dark earth sites where we see additions of manure, compost over a long period of time. And that has gone a long way to improve the fertility status of such sites. And that is what we have been exploring within the EJP project. And it's interesting with the data that has been shown that if you continue to embark on such management practices, there's huge potential to improve on the soil carbon and the soil nutrients in general. And then at the same time, reduce the greenhouse gases emission on such sites. And these are things that gives us motivation to work on in this area of research, because there are practices that we have identified are really, really working within the smallholder farming setup, which can be scaled up to ensure that we have sustainable soil management practices to keep the soil fertile and also reduce the greenhouse gases emission. So we encourage all of you to really see the output from this work and be assured that the degraded sites can be restored using the sustainable soil management practices that we have currently.
Thank you very much, Dr. Yeboah. I would say I studied the soil, we call it the forest island phenomenon in Ghana with Professor Vincent Loga. And we were able to see that those forest islands store more carbon. And when I heard about the African dark earth in Hungary for the first time, with one of our PhD students who was co-supervised by Dr. Edward Yeboah, Stephen, I was like shocked when I got to the field and I realized that carbon can be stored in a tropical system to almost 100 centimeters. So I think what you are trying to talk about, the regenerative, our farmers and smallholder communities are already doing some of this stuff, and we'll need to learn from them. Professor Eric, we are coming now to the technology and measurement. Then the question is, have you been able to identify certain technologies which can help us to better measure carbon?
Thank you, Caleb. In fact, when Prof. Vincent Loga was making his presentation, there was one of his slides where he had an auger in the field, student taking samples, and I was thinking of it. Well, what if we could automate this? What if we could put devices on the field to gather this and then put it on an online dashboard where we have researchers seeing it in real time or near real time, the funders seeing it in real time, our farmers seeing it in real time, and even the developers of people who develop solutions, either AI-based solution, IoT-based solution, having access to this information and working with them as and when the changes are happening. So within the context of our lab called the DEPA Lab, and even with our collaboration with you through our Lacuna-funded activities that we try to get, and even under the SMILE Sustainable Management Initiative for Livelihood Enhancement, these were some of the questions that came to our mind. And, you know, we are, in quotes, AI, IoT, sensor guys. We don't speak carbon sequestration, all those long English. As Professor Lugo was trying to swallow water or drink water when he was talking the fractionalization and those things. We don't understand them, but this is one thing that we do. If the soil has a physical property that can be measured, then we can develop a sensor that can sense it. So if there's a signal, we can sense, and this we've been able to do. We started first with FarmSense. So FarmSense, we launched it last year. We tried to measure the parameters of the soil, and then nitrogen, phosphorus, potassium, and then EC, and then some electrical conductivity and other properties, and then make the information, feed it with some weather information, and then some machine learning analytics to do that. That was the first step. Then it came to the difficult task of measuring carbon. So carbon, I thought it was easy, but with interaction with Caleb, it's not as easy as measuring NPK in the soil. But carbon is very, very tough. So then carbon extra came in. So with carbon extra, that helps sensors that can be placed in the soil to measure the carbon level, and then not just measure it, right? Measuring is, in as much as objective, can be subjective, but can it be verifiable? So once these carbon levels are being measured, then can this information be written to a verifiable platform backed by blockchain so that it can be trusted? So through Carbon Extra, we are doing this. And in fact, with respect to, if you look at where Professor Luger's picture where you are using Oga, this is being done real time, it's being put on the platform, people are seeing it. And what you are even seeing is that now it's becoming, it's generating, it could generate, let me say it could generate because we just started. There is a company now, Vaxos GPT, that has developed a solution based on the data that they are just waiting to plug in. So once the data is being put on the platform, they get Vaxos GPT. Basically, you can go to vaxosgpt.io. What they do is that once they plug in, then they create access to carbon market for smallholder farmers. So data now is generating what? Money. So I think it is efficient. So instead of gathering the soil samples, taking it to the lab and measuring it, now we've cut short the timelines. You have a sensor in the field, it's measuring, put on the platform, everybody can see it, and then verifiable. So I think technology now is making our lives easier. And that in the Deeper Lab, through our collaboration with you, we are beginning to see some of these things bear fruit, even in the life of smallholder farmers. Thank you, Caleb.
Thank you very much, Eric.
Just maybe I can add something. You mentioned about the artificial intelligence, and then it is a good thing, but also we have to be very careful with that. I mean, sometimes it's a lot of extrapolation that can be not completely real, a word, and then it can be now. It is at our institute, at the INRA Institute. Now there is what we call the, we have to be, there is a special word that we have to use because the ChatGPT can generate the experimentation and then with randomized things and for many years. But when you click on these experiments, it never exists. So you can have this set of the data and then publish this data, and while this experiment never exists. So this is a kind of things that we have, and our institutes are taking really seriously this problem, but also some of the journal, because you need. Another thing that what we really can help is that having some of the technology that can help us to assess if carbon is complicated, carbon stock is complicated, but I still believe that we need a different combination of measurement. We need to apply the satellite. We need to apply field measurement. It is the most important thing is the field measurement. And then, of course, having this information together with the help of the artificial intelligence to put all of these data together. But I don't think that just with the artificial intelligence, I can't say really that you scan this thing and then you have an amount of carbon per square meter, but then and the evolution real time of this thing. We need to have the hand measuring all of these things. Something that is now it is a big discussion also in France, but also started to develop and across Europe that people they use. We have these things that have been also developed in Australia. They use the satellite images, and then they use also some of the carbon measurement, and with some help of the modeling, they can make an assessment of what may happen with such a practices in terms on how these practices, in terms how they are changing the carbon stock. But the problem is that all of this mobile, because it was a market behind, this is MRV, monitoring, reporting, and validation, because they need to earn money, and then they have to run after the money with always. And then what happened is that they measure some of the point in one plot or something, only few numbers of carbon, and they change the measurement from the carbon in the vegetation, put it in the model, and trying to translate what carbon and vegetation, it is also carbon stock translated to mood. And then carbon vegetation, this is not carbon stock. So it's providing a kind of raw images and then not trustful images and how this carbon is moving. So this is a different way. I agree with the technology, but we have to keep an eyes, we human and scientists, that to have something really accurate and not just running after money and then provide some number for policymakers that they cannot start with it.
Thank you very much. Just to follow up, I agree with you on the point of artificial intelligence. So if you look at our solution, it is first from the human level. There is expertise that has been gathered. Then we build sensors. So basically all the parameters that the researchers or the experts look for, we build sensors. So I said if it has a physical parameter that can vary in a way that can be characterized, we can develop the sensors to measure that variations. So the sensors have been developed based on the expertise of the researchers. And then we go another layer to validate it. Once the validation is done, then we place the sensors on the field. So artificial intelligence don't come in at this stage. So we put it on the field. That is what we are doing under Carbon Extra, right? Remember, even with the sensors being validated and all those things, we still don't trust the data as a correct measurement. So it has to be, in quotes, immutable. So blockchain, we add another layer to it so that it can be trusted. So signed by an expert to say that, yes, if this is it, then that is it. So triple, you can call it quadruple layer of verifications, and that is that. We don't trust AI. I agree with you. AI, we all know the case where AI wrote reports with unverifiable references and all those things. So, in fact, even Caleb will never agree to us using AI. But the AI comes in when it comes to seeing the variation. Once the data is placed online on the public platform, what value can be created out of it? That is where AI comes in. But I agree with you. Thank you very much. Yeah.
Okay, then we're going to David. Are there some methods, cutting out methods for accurately measuring carbon in Europe, which we can learn within the African terrain? Because almost all what we're discussing today, what is coming out is the uncertainties in the measurement. So you have a lot of experience when it comes to some of this data, and we want to know whether there are some methodologies which are certain to sharpen our measurement of the carbon.
Well, the traditional way of measuring carbon, of course, is to take a sample and then use a carbon and nitrogen analyzer. So if we take a sample of soil, if I take 10 centimeters of soil from the ground here, and I put it into a vial and I take it to the measurement, then the uncertainty is really low. The uncertainty is enormously low in that sample because of the techniques of measurement. It's precise, it's well calibrated. What the question is how do I then transfer it to the carbon concentration in this room or in this university? The spatial variability is enormous. And that's one of the biggest challenges that we face. And being able to do that is expensive because taking large numbers of samples and putting through the lab is extremely expensive. Following on from what these two gentlemen were just speaking about, my colleagues in New Zealand are using mid-infrared and near-infrared spectroscopy. And this is much more promising in that you can, of course, do it on a sample of soil, but it, as you mentioned, it's looking like it can be done from space. It can certainly be done from airplanes. And as a result, the whole cost and the certainty is going to be lowered. Well, the uncertainty is going to be lowered. The cost is going to be lowered. So we should be able to expect much more capability of measuring the carbon concentration of soils and spatially scaling that as these techniques develop.
Thank you very much. And then the next question, which is still similar to what we are discussing, will be how might cross-continental data harmonization help in all the uncertainties you are talking about? This goes to Dr. Yeboah, yourself, and then Abad.
All right, thank you very much. I think harmonization of protocols becomes an important criteria to look at. That is why within the work package 1, you realize that we've taken pains to really harmonize the data collection protocols, say that we have what we call the fair principles of data sharing. We need to share the data, and we need to be sure that the data has been collected and harmonized. You heard David when he was speaking, that one of the major challenges we are facing within work package 2 will be the harmonization of the data that has been collected. So it's a critical part that we all need to see how we can overcome it. But there are established guidelines that we have all agreed that we are using within the project so that the data is harmonized. And if it is harmonized, then the output of it can have national implications and then global implications. So that is how we will be able to work across scales. Because at the end of the day, we are managing soils across landscape, not just within a specific geographical area, but if you want to feed a country, then you are looking at it at the national scale. And some of the things that are emerging from the project would have direct implications for sustainable soil management in our own environment. And then at the regional level, we will be able to really put it at the continental level and then at the global level. That's why currently we have what we call the African Union Soil Observatory, trying to see whatever comes out of the national data collection, which has been harmonized, can now be escalated to the regional level and finally at the global level. So we are looking at comparability of data from the national level to the regional level or the African level, and then at the continental level. So here we have the European Union Soil Observatory to look at the European perspective, and then the African Union Soil Observatory, which is being informed by data from the nationals to inform the monitoring at the regional level. So yes, but all these things would have to be done using a harmonized data that is comparable. So that is how we can work across scales and then across continents. Thank you very much.
David, do you have something to add?
I can just add to that, in the sense of course, we all have a lot of archive soils in our, hopefully most countries have archive soils. We never throw a soil away. Once we've done an experiment, we always keep it. It's so precious because new techniques are coming along all the time. So all of these new techniques for estimating or measuring soil carbon, they all need to be calibrated against a true chemical test. And we've just said that the chemical tests are expensive. But they all need to be calibrated. And the more we can push those boundaries of different soil properties to increase the sphere of calibration, it will increase the certainty that we have that these techniques can be used on a wide scale.
Yeah, when speaking about the harmonizer, it is one important thing, and I fully agree with what's been said, is it just to agree on how we are going to express the carbon. I mean, we have a huge difficulty, some of them they express in gram per kilogram, other by milligram, other by hectare. So we can spend huge time to put all of this data to express it in a way that we can really assess what's going on in terms to make this data comparatively. Another thing, if we have this across scale, so I think it will be really worse to compare the site here in Ghana with the site in Europe. It makes no sense. I mean, because we have different pedoclimatic, we have different management, but the comparatively should be made, and this is what I join what has been said by David and this morning in terms of modeling. The modeling would help us to see at what extent this soil or this type of soil is responding based on pressure, and what makes this soil more vulnerable to pressure compared to the other. So these things, and you can do it only when you have a set of the data, homogeneous data, very accurate data, and then strong data. You can do that across scale.
Thank you very much. We are now going to policy people, because almost all the things we are going to do, if we don't translate them into policy, then it ends virtually here. Yeah. So, Professor Nimo, he has been my professor for a very long time, too.
Okay. Thank you.
So, I'm still a student going to ask my professor a question. I'm thinking that most farmers are looking out for money. So, anything you are going to talk about, which is not going to translate directly into their pocket, then they will be shying away from. So the question is, some of these regenerative practices and things we are talking about, can they translate to money for the farmer, something like carbon credit, or do you know of any other scheme that is available?
Okay, thank you so much, Dr. Caleb. On behalf of our provost, my provost, sorry in the morning we were not here, just to say that before I continue. So there were other meetings. Provost should have been here, likewise, VC. Yeah, so thank once again. I think looking at the soil scientists, I was also a bit surprised to even hear how difficult it is to even measure carbon, which means it's a major problem in terms of our food security and others. And we all understand how important carbon is in terms of food production. So the question is, over the years, we've observed a trend in terms of carbon emission. I think it's now trying to a bit, slow down. But we realize that if the carbon we have in the soil should emit, then seriously we're going to suffer in terms of our food production. But coming to your question, then let me put myself in the shoes of a farmer. What the farmer will be expecting to hear is, okay, carbon, how is this? How do you capture this carbon? And where is it? How is it going to increase my performance? Which is a very important socioeconomic issue. Because we know we cannot see the carbon unless in the lab or so, though we can see the trees and the leaves and what have you. And we have atmospheric, and we also have what? The ground, soil carbon. And as a farmer, or for food production, where we also understand they are rational beings. When we say rational beings, we understand that they are highly influenced by, factors that affect their decision-making. And like every investor, you want to invest where you maximize your utility, where a cedi you invest must yield to a return which is far higher than how much you invested. And the carbon, we see it manifests itself in diverse ways in terms of ecosystem services. And we all know the various ecosystem services, that is the provisioning, the regulating, the supportive, or the supporting, and the cultural. You take the first three, the provisioning ecosystem services. I think that is where farmers really understand. They want to know how much I'm getting from a hectare, which is the provisioning, the food production. But we realize that the carbon and other factors, they also contribute to the other ecosystem services or environmental services, which we call them the non-market values. They are not in the market. For you to go and buy, like, I have cultivated rice, so this is how much a bag is. So the other services called the regulating, where in terms of water infiltration and what have you, the soil becomes very, very important in doing that. And the presence of carbon to hold the soil, properties is very, very important issue. Then the supporting services, We know the flora and the fauna, if they are not there, crop production will not even perform. And the carbon binding the other elements and molecules together. So the question is, how do we maintain the carbon, asking the smallholder farmer who is interested in the provisioning services first? Therefore, carbon market becomes very important. In Africa here, we have Kenya. I think Kenya is leading. And over the years, Kenya, Zimbabwe, Gabon, and I think Tanzania is trying to now, put in place a policy document for that. And Ghana, we have to, and we are happy this conference is happening. Ghana, we have to speed up. So through the carbon market, farmers are able to get some incentives. Because the reality is, for us, I use the word, they are rational beings, and for every human, we have what we call the self-satisfying goal. Then it goes to the profit maximization goal. So the self-satisfying goal, every producer will first look at what he will get in the first instance, then what goes to the public. So what goes into the public, which is the carbon we are discussing here, if an individual farmer should invest in that carbon, it goes beyond just the provisioning to the other environmental services. And therefore, we all benefit. But the big question they always have is, have you invested in to you to also enjoy? So some of the measures will be, and it's expensive, as we have said. Even the soil analysis before you know the farmer, this is how much carbon that is present in the soil, so you should reduce the amount of soil management practices. It's expensive. So the carbon market, therefore, becomes very necessary in terms of incentivizing how much the farmer will need to do some of these investments. And over the years, appropriate ministry in Ghana, Ministry of Environment, Science, Technology, and Innovation, through EPA, they've done some studies where a project called Sustainable Land and Water Management Practices, where there are short-term and long-term measures to keep carbon and other ecosystem services. So the reality is, if it's expensive for farmers and for these short-term measures, like you go to the north, the stone bonding, the cover cropping, the composting, and what have you. Some analysis have been done over the years, and you realize that in the short term, they are very expensive, but in the medium to long term, they pay back. But we also understand that as rational beings, we say, generally, people prefer current consumption to future consumption because of time value of money. If they, do I have to compensate you now for investing in something that will benefit society rather than to give it to you in the future, which one will you prefer? And studies have shown that a number of people will say, I want the current consumption. So the initial investment, which will require these supports, must be there. And how can this be done? Through making intentional efforts, through giving some premium, especially if I have cultivated mucuna or puraria to do my plantation. It's also organic, minimizing, inorganic fertilizer. And therefore, whatever I get as my produce will be organic. Am I getting premium price for that? That is also a question we have to ask. Then other incentive measures, I think we can help, promote this. So in a way, you are right. Trying to promote the carbon market, farmers getting the incentives, identifying whatever products they are producing, getting premium and what have you, will motivate them to go into practices that will provide not just provisioning, but the externalities, which are the non-market values for the benefit of all of us for, food security and sustainability. Right. Thank you.
Thank you very much.
Just if I fully agree with the carbon market, but you know, in Europe now they are keeping away from this carbon market because it was a kind of, let's say, a misleading situation. And the reason for that is that they are not paying the right price. It's still very, very low. I mean, you can't as subsidized, you can't fly up these things. I mean, it's really, and then the only, part taking benefits from this is the polluted industry and all of these things, because they said they can pollute as much they can, but they can put only in compensation only a small price that can be goes to the farmer. But this price to the ton per hectare or ton per CO2 reduction, it's still very, very low, very low. And then in Europe, last week we have been in a meeting because of the observatory, and one of the ladies, this is a new person, she was in the ministry, and then now she is the head of the scientific direction at the INRA. And when I talk about the carbon market, she said, please forget this word and let's talk about other things. So and then many people now, it's really getting away from this just because the price was not much in the reality.
Smallholder farmers, they will say in the absence of nothing, bad is good. So, in the I know in the European context, it is nothing. But our smallholder farmers are people who are selling their prized land to galamseyers for some pittance. So, if it is possible to maybe create alternative livelihood from the carbon market, maybe then in the absence of nothing, that can be explored in the meantime.
I fully agree. But if you have a total energy come in and taking some of the land, and then they have to pay only some cent, it doesn't help. They have to pay the real price, real price. Because, I mean, it is what's happening in many of the European and African countries, and because they buy the government, they buy the president, and they can pay what they want, how much they want to pay. But it's still very, very low, very, very low.
I agree.
But to add quickly, yes, it is, especially if you say then the recommendation would be government should do this, which has been becoming a norm, which is not sustainable. So the reality is there could be other models, either the PPP, the public-private partnership, or even government-owned institutions. The reality is it becomes necessary for us to look at the medium to long-term effects. In other words, then you look at the cost-benefit implications. For instance, if a land is degraded, and like the galamsey we have now, the water is polluted. Now you see Ghana Water Company is crying. Not that crying, but it's a state-owned, which we all benefit. So you see the tariff is now going to be slapped on all of us. So doing the CBC, the cost benefit analysis, then you tell yourself that every year, a company like Ghana Water Company, if we are to do our processing, we spend X million dollars. Now, the preventive measure will be if we incentivize and we go for good agricultural practices. Is it possible, let's say we spend X amount annually, then we are to provide this incentive, not directly from government, but to support. Is it going to be X minus maybe Y or something, X minus X2? Are you getting my point? So as a preventive measure, you come in and you collaborate rather than to continue to spend huge amounts of money. So collaboration could be with Ghana Water Company, the Forestry Commission, and all those institutions looking at their annual budget. And the big question is, if they were to support with an X amount of their budget, would they be better off in the medium to long term rather than to leave everything like that? therefore it becomes prevention is better than cure. Than we wait, everything spoils, and you come back. You get it. So you look at the cost-benefit implications, and you are able to make some recommendations. Right. Thank you.
Thank you very much, Prof. I think you've been able to. We'll come to the question very quickly. Yeah. So the question is, you've been able to touch on even our last question that should be on the partnerships and this. But the question now is, right from the beginning, we are even talking about the monitoring, where measurement is even still an issue. And when you talk to some of our policymakers, I speak to EPA and others, and they tell you there's money available, but do you have a monitoring system that can be able to do the monitoring, the verification, the reporting, and probably the validation as we're talking about? So I think that is where we are going to. Something which can be able to do this, which almost everybody within the chain will consider trustworthy. And then as Abadi say, those coming in should not pay peanuts. They should be able to pay real value for what the farmers are saying.
All right. I think currently we have the monitoring system in place and then the reporting system. The UNFCCC system is there, where even Ghana, we are now working towards using the Tier 2 reporting. So if we report based on the IPCC guidelines, then this becomes a credible source for really verifying all the things that we are doing. So I will encourage, even within the consortium, let's be sure that the participating countries are also reporting using the established IPCC guidelines. In Ghana, we always report on that, and EPA has been doing very well on that. And within the last few years, even within the livestock sector, we've now even worked towards using the Tier 2 reporting, which is quite encouraging. So yes, the IPCC guidelines are there for us to follow, and that becomes a credible source to use when it becomes necessary. Thank you.
Okay. Dr. Iboa, you are not running away. In our sphere, you are one of the kingpins when it comes to soil carbon. And the question is, do you have any evidence that people working within the soil carbon storage are getting money? I don't want to say credit, but what the farmers will understand money for their...
From that, I can say yes, because when you go with your sustainable soil management practices, I've been working within the recarbonization of soil using the FAO guidelines and then protocols. With the sustainable soil management practices that are in place, we've worked across various sectors within the country. And when you have improved on your soil carbon storage, it translates into money for you in terms of the yield that you are getting. Mm-hmm. So even if you are not selling carbon per se, you have the alternative livelihood improvements, which is translating into money and brings you a lot more joy and income. So that is the benefits that we are having in the country. You move to the Laura area, the Upper West region, and you see farmers themselves being motivated to use sustainable soil management practices for their own fields, not with incentives. They themselves do it on their own, and they improve their yields, and they are happy. They are happy. So I think that's the joy. For me, when I see people using the technology available to them and transform their own lives, I think there's nothing more to it than this. Thank you very much.
Thank you very much, Dr. Iboa. To be frank, I was asking that question in this respect. Example, Dr. Erasmus Tete is not here, but I was going to use him as an example. Somebody who is having about 200 to 300 acres of something like rubber plantation, which all what you need after the 5 years is good rainfall, which will give you a whole lot of rubber yield. For example, if you are including something like biodiversity on their farm, where they can be able to replace some of the rubber trees with something like agroforestry trees, at the end of the day, for him, every rubber tree on the farm gives him money. He is not going to think like the smallholder farmer in Ghana. So for such people, and even some of our older farmers, we believe that they must be able to get extra money for cleaning our environment. What do you say?
Yeah.
Okay, Prof, you can say something.
Yeah, I think it's a very good point. You see, that is indirectly farmers who adopt, they tend to benefit. And it means they would have understood the whole concept and they look more into the future, right? But usually the reality is how to get them to understand, which probably will be part of the sensitization, the education. They really need to understand that. Otherwise, they will still go back and think about, is it personal or externality? So it's so true, and they are able to get indirect benefits in terms of the yield differences, and studies have shown that those who do that over the years, gradually, they tend to be better off than those who do not adopt, those practices, right? Just one story. One of the studies we were doing in the north, and an attempt to promote sustainable land and water management practices. We were on the field, and a young farmer we were talking to, and we heard a voice from an elder farmer in the local language. Then we asked, what did he say? He says, you people, I'm going. If you use your land for tree growing, you see what you eat in the future. Right. So that's why I brought in the idea of the understanding the concept, the education, and what have you. Right. So indirectly, it's true. But you see, as I said, human beings will want to see, so it will call for, beyond this project, and as we are moving on, we should be able to gather data, analyze, inform. And I like the idea. It should be more like, we say every year our GDP is increasing by this. In Ghana too, as policy-wise, we should have that. They say, what is the total carbon relative to the previous year? What are the dangers? And the promotion must continue so that we all appreciate the fact that if you play with this carbon, we are all going to, perish, right?
I could add, I've been very encouraged by hearing these stories of farmers being very happy because they're apparently gaining soil carbon, but they're also increasing the money through the yield. But I think we just need to bear in mind there are enormous trade-offs often. And certainly the systems I work in, the temperate, highly managed graze systems, then you can't have both. You can't have increased carbon stocks and you can't have increased production at the same time. And often what happens is that our systems are losing carbon, where the farmers, as we were talking earlier on about this, the farmers feel they're gaining carbon, but they're not. They're losing carbon because they're exploiting the system and removing so much of the biomass that there's not enough carbon going back into soil again. My point is it's just not always a win-win. There's often compromises need to be made.
Oh, okay. We've been able to exhaust a lot of our questions, and I can see already hands coming out from the participants down. So, Dr. Amani.
I think that the panelists already realized my question and decided to start answering it even before I ask, which is quite interesting. I think Prof just actually made mention of that. We have to be very careful of the trade-offs. And I am somebody who is very cautious when it comes to this kind of new development in terms of sustainability and then new financial flows, because I've worked in forest certification for a long time, and I know how it always starts with the motivation, enthusiasm of what you are going to benefit once you implement it, and I know once you implement it, the issues that come with it. Having said that, so soil carbon is obviously, if you can enhance soil carbon, it's obviously a good thing. But I don't know his name, but he just mentioned it about the trade-offs. These are very important, and we have to be very careful about them. I'll give you an example. In northern Ghana, crop production is one aspect of livelihood, but then we have livestock. If you're focusing on carbon, obviously you're going to change fire practices and you're going to change grazing practices just to enhance soil carbon. What are you losing? Livelihood. If you focus too much on carbon, also in the savanna landscape, which I'm a savanna ecologist, so I understand this pretty well, what are you going to do? You're going to change fire practices, and you're going to change grazing practices, and you're going to increase tree cover, for example. What do you lose? Biodiversity and livelihood. So I think in this discussion, we have to be careful. Where does increasing soil carbon help, and where do we pursue other alternative sustainable development agenda, right? We always have to balance this to make sure that we don't try to, in fact, my biggest question is how much emissions do we even produce that now we have to worry so much about capturing carbon and reducing our emission just to get, like Doc said, something really small for conserving carbon. So we always have to be very careful about this balancing and also articulating or framing the question in a way that is beneficial to us and not just focusing on one silver solution, soil carbon. If I go to my forestry people, they will tell me reforestation, the solution. You look into that, then you start seeing the problem. So we always have to be very careful about these kind of dynamics. Thanks.
Thank you very much, Dr. Amani. Does any of happen?
Yeah, thanks very much, Doc, for this submission. It's quite important. It's all about the trade-offs. But you realize that if the soil stores a lot of carbon, the smallest change translates into so much tons of CO2 or greenhouse gases that are emitted. So we are very particular about the little changes that takes place because it translates to a lot of greenhouse gases that are emitted. So we are mindful of that. We always need to look at the trade-offs and see which sustainable management practices will really help us to sustain our productions. In the traditional northern regions where we've been working, we always come out with the farmers identifying the sustainable soil management practices. And we analyze their soils to know what is there. And based on what they have accepted to use, which does not conflict with their livelihood options, then we go in with those. So we are not sacrificing livestock production at the expense of crop production, but we explore the sustainable options that are available. It's not an easy task because if you still want to move at the crop production level, somehow, the livestock sector also is also affected. But we always try to have what we call a balanced options based on the farmer's own criteria and their own assessment. So that is the way to go. But it's quite important for us to provide the data to really look at the policy issues. How much do we need to sequester? At what extent? So that we will still be able to operate in a sustainable manner and then also be able to reduce the greenhouse gases emission. It's something that we need to explore different options to come out with a compromise options that policy can support. And that data we have to provide and provide the guidelines along that, which is evidence-based. And that is a task that you and I would have to work towards and help the government to really take decisions based on the available data to know the trade-offs. Thank you very much.
I think these are real issues on the ground about trade-off. If you go to northern Ghana, for instance, the farmers don't produce enough biomass. So they have to still feed that to livestock and at the same time putting some into the soil. But one thing we also look at is that when they feed to the livestock also give manure that can also be used to put back into the soil. So in complex agro-silvopastoral system, you have the food crops, you have the tree crops, you have livestock, and these are more or less integrated into one system that is very much robust. And then what we also guard against is that our friends in the animal science industry, they know that even urine from animals give a lot of nitrous oxide emissions, methane emissions coming from animal production. So these are also pathways for soil emissions. If you look at the smallholder farmer in a way, emissions are not much, compared to what we do in Africa, but we still want to be, all around, so that we have good practices that are in place. Then, so I think that's what I want to say for now. There is some there, but it has escaped me, so let me leave the rest.
I agree with what Prof is saying, because sometimes we will need, and what Dr. Yuboah said, sometimes we will need to give policymakers real data to be able to, or we even need to even synthesize that data for them, because the first time I heard that because of climate change, we are going to stop almost all ruminant production, I was like, would this be possible in northern Ghana? So some of these things, we will need to look at them critically. I think Emmanuel raised up his hand for a question.
When it comes to this carbon saturation concepts. So the question I'm asking is, we are interested in increasing carbon, but when it gets to the saturation level, what happens? Where does the carbon goes? And is it good that we always increase the carbon and at the end, we end up getting to the saturation level where we don't know where the carbon will
go? Let me help. The concept of carbon saturation is a very sensitive issue. A lot of debate in literature about carbon saturation. Others refuse that idea that there is nothing like carbon saturation. Because if you want to, the idea is that if you continue to add carbon, the surface area of the soil, in terms of the mineral surfaces, are going to be exhausted. So they cannot hold carbon on the mineral surface again. But there are a number of ways that have also shown that if you have, we need to be more looking at net primary productivity in the system. So I really want us to a little bit, the concept of carbon saturation is highly debatable. Okay, people believe there is nothing like that. And whilst others believe that it depends more on even climate. If you look at our temperate soil, for instance, high temperatures will foster a lot of decomposition. So storing carbon will also be very, very low. If you go to where we have well-managed cropping systems, carbon decline with time. And what is causing that? It could be drainage, it could be decomposition, a lot of factors. So I stand that carbon will never be saturated. Thank you. I don't know what about
I agree, Professor.
Hello. We will come to our panelists also to also give their point.
Yeah. Okay, Emmanuel, I'm still coming back to this issue of carbon saturation. We have added organic resources of different quality and different quantities over a period of time. And in tropical environments, in almost all cases, the decomposition rate is so high with water and temperature, everything, even the recalcitrant carbon, are all decomposed. And they are not there to cause the saturation that we are thinking of. So let's continue to build up, which is still expensive and difficult to build, the carbon in the soil. But if we are able to do that and get our productivity improved, that will be the way to go. But we will never get to a point in our tropical environment where we will have the carbon saturation taking place. Thank you very much.
I add to that, both Vincent and Edward, I agree entirely. The feeling, I mean, the current evidence is that the mineral saturated carbon can become saturated, but there's also the particulate carbon, which can continue to increase. And then the question is holding on to that, making sure that is not vulnerable to decomposition. But as it happens, I mean, if you measure the carbon concentration in lots of soils, very few of them are saturated. There's no, and particularly if it's managed in any way, then there's still opportunity to increase it further. And of course, that's even more magnified in subsoils. So many of us measure down to 10 centimeters or 30 centimeters, but there is the potential below 30 centimeters to increase because it's hardly ever saturated down at those lower levels.
Yeah, David highlights a very important. One advice I should give you is that we are all dealing with agro-ecosystem. And from theoretical point of view, all agro-ecosystems are losing carbon. So there is a huge potential to increase carbon first before talking and losing our time and the needless discussion about this saturation. Saturation is happening in some, let's say, some native forest, some peatland forests where we have this kind of specific soil. But as David said, most of the soil really need more carbon. We have a big problem, and particularly in the subsoil stuff that we need, if we are talking about the topsoil, so we need to increase carbon in subsoil. So maybe this is a way how to think about. But I know that now some papers are really coming, trying to discuss and making a lot of theory about the saturation stuff, and but it is, with something that we should spend our time in more important things instead of discussing something that is not.
Yeah. So, Emmanuel, you've gotten a whole full idea about the whole print. Yeah. No, but to be frank, the first time I heard about carbon, the saturation concept, I was like, this can't really happen in tropical system. Yeah. But when we got the soil judging in UK, that was I coached the Italian team and we were the second. But what happened there was we were able to insert one of our this one, I've forgotten the name, but it's something like a small metal down into the soil to determine how deep the pit soil was. And it was extending more than 4 meters. So the idea came into my mind, the European can easily think about what a saturated carbon can be, but within our system here, we don't see it. And then what we are even opting for farmers to do is make sure that what you are inputting, we are taking from the farm, you are inputting back. But the question is, where are you even going to get the back from? That is the plant material. So that is how we just have to look at the question. Please, any other question?
Yeah. We should not debate so much about saturation. It's a very hot issue in the literature. Thank you.
Thank you. Going to add that, the first question is like, when would the sea be full? Or when would my pocket be full? It's like in the olden days, we used to say poverty alleviation. You know, it has changed to poverty reduction. And there are so many factors. I can see there's a very big gap. We are rather trying to close the gap. And as you attempt, due to so many socio-economic factors, pressure, population, and what have you, climate change, so political issues, so the sea will never be full. Right, thank you.
Thank you. Mine is a little bit deviation because I am an animal scientist. I always try to bring myself in because most of the time when we are talking about climate change, it's more or less like the animal sector is put to the background. But considering what livestock also generates about 8 to 18% greenhouse gas, especially methane and then nitrous oxide. Now, if we go to the northern part of Ghana, because of the nature of their rainfall pattern, they have very little vegetation for animals to graze on. So what we are discussing here, how do that benefit people who are not even finding forage for the animals? How are they going to put them back into, because most of them will use their crop residues to feed the animals. So it means after harvest, they cannot allow the residues to degrade to increase the carbon. And remember, if the animals also consume more of these low-quality roughages, it also increases enteric fermentation, which results in methane production. So how do we go on from here?
To our panelists, and I think the questioner will also help us to answer this question.
Yeah, okay.
Okay. It's true. You see, not long ago, there was this issue of farmer-herder conflict, not only in the north, but even the middle belt. And some studies from our own students, high-level PhD students, have argued strongly that wherever there is green, it is for the animals. So you see, there's always that issue of animals versus crops. But it's also true that if we're talking about sustainability, agribusiness, you want to do this farming as a business, studies have shown that the establishment of grazing parks, let's say you are an animal farmer, that is from the private perspective, will let you be better off than to even leave your animals, to graze. And either is the animal science conference that I even learned this, that people who are able to keep their animals and they feed them, they get better, mass, you see. So there should be innovative ways. On the national or policy direction too, this is where attempts are being made to establish specific corridors, grazing corridors, you see, so that we know animals within the sub-region, these are specific, grazing areas, so that it won't be at random for the exploitation to happen. And it's a way we can all find to manage the system. Right. Thank you.
Because I think it's a very important issue. And part of the problem when it comes with this livestock is also the way the management setup in Ghana works, right? So if you look at the livestock sector, it's under the Ministry of Food and Agriculture. When you look at the corridors, so the natural areas that you are talking about, it's under the Forestry Commission in the Ministry of Lands and Natural Resources. So there, the policy overlap is really shaky. And that's why because we have livestock that depend on rangelands, but the rangelands are managed by another organization, another institution. So in the case of Ghana, if we really want to tackle that aspect, we have to also look at the policy coordination, in addition to all the interventions we can put in terms of, let's set this place aside. But if we don't fix the policy aspect, there is no way it's working. And that's why it persists all this while. People make this, how to call them, these gray zones that are kind of enclosed. And it doesn't work because we don't have enough space for it. We have a lot of animals, and you create these small areas like the Wawasi project. It will not work. So actually solving that part for Ghana start with the high-level policy coordination in this space. I think that is very important.
I think we've been able.
Let me make a contribution to Dr. Aidan's question. Mostly, if you want to reduce those emissions from livestock, I know sometimes you add some additives to the food. You try to, manipulate your feed to reduce emissions. Some people add seaweed to just cut down the emission. And then also, you look at manure management, how you manage your manure well. Sometimes if you just get the manure and you leave it in the open, and then sunshine, you lose a lot of gases. So these are some of the practical ways which can be taken for the animal industry. It takes a lot of commitment. Thank you.
Thank you very much. And we have one of our top agroforesters around. So, Prof. Abunwa.
No, quite often if you are up north, you realize that the way the animals are kept, the manure, the quality of manure is very, very low. A lot of the nutrients are lost before they are gathered. So if you could, as part of the whole system, if you can manage the manure well, then we'll harvest the crop residue for them and we'll get almost equivalent amount of manure to return to the soil. And that will in turn also improve on the biomass from the crop. So it will be a cycle, and with time, there should be an adequate manure, crop residue to feed the animals and adequate manure from the animals to go back to the soil. So I believe if we could harness on that system, that cycle, we should be able to resolve the issue one way or the other.
Prof, just a quick follow-up on that. The issue is about managing the animals. If the animals are stationary or within reasonable area that they can move, then it will be easy for this manage. Most of the animals don't even return for a very long time when they go out for grazing. So how do you manage to use this manure when the animals are just dropping them one on the road?
I believe that is why some of these projects are going on, because it should be a way of educating the farmers. We know that system of allowing the animal to go free range, at the end of the day, doesn't benefit the farmer. They lose a lot of the animals. So as part of the system, the animals must be kept one way or the other, and they must be fed, even if supplementary. And through the process, adequate manure are gathered. In fact, we had a study where we kept 4 systems. One, Kajanus, we harvest feed to the animal and bring equivalent amount of biomass back. One, the Kajanus, we harvest and just apply it separately as a green manure. And the other one, we allow the Kajanus to grow for 2 years. Then we plow it in. We realize that if we are able to harvest the Kajanus, the biomass feed to the animal and bring the manure back, the system itself gave us higher productivity in terms of grain yield and soil fertility. The only difficulty was that at the end of the system, a year after it, the soil, all of the 3 systems went back to the same level, as if nothing has been applied. So this issue of saturation virtually doesn't exist, because the system just reverts back to the original system because of our environment. So I think as part of all these projects, the farmers must be encouraged to have a system of managing their livestock. And in that process, they can harvest the manure for soil productivity.
Yeah, and just a little contribution to Dr. Aidan's concern. You know, you have been currently working on the livestock sector to really see how you can improve on the greenhouse gas emission using the Tier 2 methodologies. So all the output that are coming on can one way or the other guide us in the management system. So your feed quality, if you are able to improve on the quality of the feed, you are aware that you also be able to reduce the emissions that comes out of it. So let's focus on those aspects and see whatever management practices that will be available, say that the animals that are more or less in the transhumans, you will be able to see their contributions to emissions and be able to quantify. Therefore, when we are designing the management strategies, we will know that those that are impacting negatively on the greenhouse gas emission, we try to avoid. So it's not an easy system. I admit it's not something that is a silver bullet approach that you can use to really reduce the emissions from the livestock and at the same time use the animals' residues to improve on the
soil management practices. It's quite a bit, but it calls for really a review of the system and then the managing of the available information to guide us in decision making. So it's something that we still need to explore and come out with how we can really reduce our emissions and at the same time improve on the soil quality indices. Thank you very much.
Okay, I'll add one more thing. So in the exploration stage, there are some of our postgraduate researchers working in this area. Lemuel is working on Headwatch. He's making a presentation on Wednesday. It will be very good for you to listen to it and then see which aspect of his tool can be maybe retrofitted to make some of the measurements. That would be very good for policy-informed decisions. Yeah. So on Wednesday, that is happening. Lemuel is here. Yeah.
Just to follow up on Prof, I think given the importance, especially of the livestock issue, I personally am surprised that Ghana seems to be one of the few countries in West Africa where we don't have like a rangeland policy, especially in relation to the livestock sector, to bring in all these issues about emissions and sustainability and how you are going to deal with that. So, Prof, that is an area that, I don't know if this project covers it, but that's an area that we definitely need to start looking into. We have agricultural policies, but when it comes to the aspect of the free ranging and using the natural areas, I haven't seen any policy on that. And I've been looking at the natural resource policy of Ghana recently, and I don't find much on that.
Okay, thank you very much. I think we've had a very good discussion on the subject matter. And as Amani indicated, he is interested in the savannah. So am I, in the sense that if you are talking about only keeping animals in closed setting, for some of us, we are also not too happy about this because the fertility of island concept also comes in. We believe that a lot of the forest patches we have within savannas come from some of this stuff, which also benefits the environment. So some of this will need to have much more broader communications on them. Luckily for us, a month from now, from the 24th to 28th, at CSIR, Crop Research Institute, we are coming out with a monitoring, verification, and reporting device, 10 of which will be spread across the country. And the knowledge hub for that one is Deeper Lab, KNUST. We are doing this in collaboration with Embrapa in Brazil, and then the James Hutton Institute in the UK. So most of the stakeholders within the Ghanaian sphere, you will still be invited to come to our place next month. Thank you very much. Yeah. So please, we'll take a small picture with the panelists before.
Right, thank you so much. Please appreciate them. That was very, very educative. That was very educative. And for somebody who knows nothing about agric, I think I learned one or two. Appreciate them. You can do better. Oh, we are tired. Okay. You're welcome. I think that the hours we've spent here have been very, very fruitful because this is some information that we all need one way or the other. We are literally done with the whole program. But if you check out the program, you would notice that there's logistics briefing and then practical notes for the week. So it's actually a document prepared to help us stay, make it quite easier. It will help you navigate your way around, the numbers to call in case you need some assistance with your health, with changing your currency, anything at all you want to be helped with. You can kindly scan the side of this document. So if you have it, you can just scan here, and you would have access to the program outline as well as the logistics briefing, where the contacts are available and all of that. Now, what we are going to do is that from here, we are going to take lunch, and we are going back to where we took the breakfast. And after the lunch, we are going to have a tour, both in KNUST campus and any other place that our tour guides would deem it fit that we need to see. So please, let's take notes and then join in when the time is up. Once again, if you check the program outline, you will see that there's a name here, moderator, Mr. Emmanuel Kwesi-Debra. Unfortunately, I'm not Emmanuel. My name is Millicent Safuedu, and it's been wonderful having you here. Thank you for the cooperation, and thank you for being here this afternoon. Have a good afternoon and enjoy the rest of your week. I think we are done. You can clap for yourself for being here and all that. Right. So we can just go ahead and have the lunch, and then the other things will continue. However, the photo booth